Hi everyone, myself Krish Raidukar, very warm welcome to all. And in this day we talk about system design basics. So in that part we really focus on system design basics. And one more architecture to be discuss, event driven architecture, that EV architecture, like ED architecture. So overall agenda for today, like the first we discuss event driven architecture with the real world application. I take a special application which is based on real world application, like too much famous right now is like Zomato and the food delivery app. So how actually they use this type of architecture to uh, like uh, to process this order and how actually they process this particular one. So overall, we discuss lots of about this particular real world application and this abstract concept. I connect this all of the dots between both of them, and I try to explain you much better. So that's all about system design. Again, if this particular video is going to be productive for you, if you learn something from there, then it's my pleasure. Let's come to the event-driven architecture. Like this particular part is necessary for system design. Previously, we discussed monolithic and microservice architecture. That's really necessary one to discuss, and this particular one is also important to discuss. And I try to explain you like you understand much clearly. So, what exactly event-driven architecture is? So, in fact, when we're talking about event-driven architecture, so it's all about something uh, event decoupling asynchronic. So, it is all about, I think, like I will try to explain you with the three different word. I'm not going to give exact definition over there. So it is all about waiting for event. Okay, the first feature of this particular architecture. So you are designing a architecture, entire blueprint of the model, entire blueprint of the system software. In such way, like you are waiting for event, you decouple this all these particular events in different without dependency of each other. For example, I will try to explain you with a real world application, Zomato, which is basically based on this particular event-driven architecture, and I will try to explain you. This is very important for real-time processing and anything also. Okay, so in that case, in that architecture, which is basic wait for the event. Okay, if this particular event happen, they decouple their all this particular event task into different nodes and different layers in such a way like they are not independently executed all over there. Okay, and third one, asynchronic wrapper to something like it is act as a non-blocker, as sometime you are try to such as a make a payment. Okay, so in that part you have lots of options there, like the first you can choose phone pay and you online payment and sell cash on delivery. So it's all about you are not able to just give a online, but you are just it's also facilitate your app also facilitate your the software also facilitate to just a payment with a cash on delivery, COD. In that case, if they process, so that means we are not properly dependent on second step, that were not any optional steps, so we have a lots of optional steps. And in that case a lot user are not waiting for like if this particular step happened, then after we move forward, is it not enough? Okay, so if this not happen, then we move forward. If the phone pay is not working, that we move toward the COD, and there were lots of the option there, and we are not stuck in one specific step. Okay, so that's all about non-blocker, act as a non-blocker, that's referred to asynchronic. So uh, this is the three main motivation of this particular entire architecture of event-driven architecture. So that's what actually they use and how actually they use. And according to it, the main and the one of the greatest application over there and the real world application, I think, is Zomato, which is based on that. So in the Zomato, I think in that case, I will explain you like three layers of their uh, like event-driven architecture also. I try to connect this all this one. So now suppose this user order a service. Okay, they place a order. Okay, and this particular entire user place a order that called producer, which actually produce event. They trigger their event. Okay, to just place a order. So that is called the producer event. Okay, second part is Kafka broker, that event broker. The first is event producer, who actually user go the app, Zomato app, and produce a order, which is basically event producer. And in that place Kafka broker, which actually event broker. Okay, second part is event broker, and third part is event. Let me connect this whole one. So event producer is all about create, which actually produce a event. Okay, and the Kafka broker, which actually take this particular event and process it locally, which is according to the process it logically. Okay, for example, if the user place a order, that is the producer which actually produce a event. So that's called the event producer. This part is called event producer in that architecture. And that is event broker, which actually process this particular entire event logics. For example, they choose a right restaurant nearby address, okay, nearby location, and they facilitate notification service for further more update, and they choose a right delivery partner according to it. Okay, and that's how the Kafka broker and event brokers actually event broker. So in that case, event broker is all about process the event logically, and it's all about choosing a right restaurant and notification service and choosing a right delivery partner for this particular order. Okay, so that's okay. So that's all about event broker. And second, our last part is like event consumer, which actually facilitate the response. After this particular happen, your it's all about consumer side, which actually uh, okay, which particular event broker which process the all particular information logically. Then next part move toward the event consumer, which actually process the business logic, and finally it responds to the user. For example, your order will be placed and they apply business logic to payment something else, all particular things. Okay, and response to the user get order placed. Okay, so that part, event producer, event broker, and event consumer. This is three layers of the entire event driven architecture. So in Zomato, if the particular user produce a event, the event broker actually processes locally at choosing a right restaurant nearby location and choosing a right delivery partner, and all this particular event broker do. Uh, we not need to discuss it manually happen inside the system, but I don't know what the basic thing is. But in that case, event consumer is something all about the process information, business logic, and place a order. Okay, applying a business or logic, it's all about like payment and particular stuff, and finally response to the user. So it give a response to the user. Event consumer, which actually responds to the user. So in this three layer, event producer, event consumer, and event broker. So the three layer of the entire event driven architecture is really play an important role, and this is the core important layer to understand. Okay, so uh, in this event driven architecture, I think like lots of things that we should to discuss, and why this event driven architecture is important and so crucial to understand. We discussed lots of monolithic architecture, which is basically that unified code base, microservices, which are components like distributed in different code bases and different nodes which is independent from each other. In that case, key benefits, if I look toward the like loose coupling, it's loose coupling refer to it's all about something you want to create a system, but in that cases you don't know what the consumer side is. So it's all about here, you know, you only create a you only place a order, but you don't know what actually what you are not going to just handle this particular restaurant service, notification service, delivery partner, and that's all particular thing happen inside the system backend automatically. In that case, this particular one is we not need to handle a few logical parts. So we only focus on choosing a right food and place a order. We are not focusing on business logic and restaurant service notification. This both sides. We are this particular both sides are hidden in that layer. So that's the loose coupling. Okay, we know only for producer sides. We don't know what the particular consumer side is. Okay, so that's the important part, and so that's make easy to access this particular system. So if this particular event happened and that particular one process executely without any manual command anything else, so that's all. Second thing, like fault tolerance, actually what happened in their system, like in this event driven architecture. So like when we the particular model try to understand something like how actually this work, how they particularly actually take a command over there, in that cases model deals with lots of fault tolerance. For example, for increase of traffic, sometime particular product is out of stock in that particular area. If someone want to place the order, but this particular item are out of stock in that particular area, then this particular event driven architecture facilitate queue, message in queue, which is basically uh, keep this particular one as a cart. Okay, if this particular one is in the stock, then particular the user are able to just find out and just place a order. So it's all about handling fault tolerance. Sometimes system fail when you are not able to process. Okay, but the particular application and this entire architecture facility to keep this particular product as a cart, and then after if the particular the system are like good, then you can say you process this particular one and just get the product. That's okay. Second one, real time response. That's all about real time response. So we need a quick response. If you want quick response, then few part you need to be automatic, like that's automated. That here you can say we only focus on producer side, the consumer side automatically automated here, or backend logic and anything else automated here. So we not need to choose a right restaurant nearby manually and anything else stuff. So that's the event driven architecture. So for real time response, okay, each step trigger one by one without any specific command, but you need to just create only for one. As a user, you need to create only for one is like producer, as only for event. So that's all about like Zomato is focus on that user come in app and just all about just create a event, and other parts is triggered automated over there that okay. So that's okay. Okay, so that's all about that event driven architecture, and that's the basic fundamental of system design. And when you talk focusing on system design much more, and when you're talking about system design, that's the really important part and baseline for system design. And monolithic microservice is important, but that's also important part. So I discuss this one very important one. Okay, uh, as you know why we are going to discuss this kind of architecture, because of that when we designing on system we should to know actually what the basic needs of that kind of systems, what the need of that kind of software, and how actually these softwares are communicate to each other, what the layers and what the particular types. If we have a lots of option there, we can choose a right option according to the workflow. So knowledge is important because of that. If you know that particular one, then you can choose the right option according to it. That's the really foundation one, and to understand much better about our system design basics. So okay, our next part is also going on system design basic, and we move forward to their, I think like 20 to 30 videos on their system design. Because of that we need to explore much more about system design. I'm really fascinated about system design much more. And okay, so that's all about part of the system design. Again, if this particular video is going to productive for you, if you learn something for that, then it's my pleasure. Okay, see you soon.